I would like for you to say hello to my two friends that are here.
Hey,
So
hey.
Madison Reedy.
Hey, Colin.
And Lauren Davis.
Hey, everyone else.
Okay, we're going to start our lesson presentation today by doing some integer exponents. So let's get busy. There are objectives. We're going to evaluate expressions and simplify expressions, but notice that they are containing zero and integer exponents. Remember our terms for exponents. The base is the number, the big number here, and the little number is called the exponent. 2 to the negative 4 is read as 2 to the negative 4th power. Okay, here's an example. We have 1 cup is 2 to the negative 4 gallons. You have to simplify this expression. In order to simplify this, 2 to the negative 4 means 2 to the 4th power on the bottom. That's what the negative 4 means. So you have to switch it to the bottom. You have to put a 1 on top, and that's the same thing as 1 over 2 times 2 times 2 times 2, which is 1/16. And that is 1/16 of a gallon. All right, and try the next one. Make sure you write that example down. Number 2. A sandfly has to have a wingspan of 5 to the negative 3. That means take 5 to the negative 3, switch it to the denominator, 5 to the positive 3. 1 is on top. That is 1 over 5 times 5 times 5, or 1 over 125. And that is equal to 1/125th of a meter. Number 3. I have a negative exponent. This needs to go on the bottom. So that's going to be 1 over 4 to the positive 3. And then that's 1 over 4 times 4 times 4, which is 1 over 64. Number 4. Anything to the 0 power is equal to 1. Now, if I had a negative 7 to the 0 power, that would be negative 1. And if I had a negative 7 to the 0 power, guess what that would be? Yep, that would be positive 1. Okay, number 5. This negative 4 means that I need to write all of this on the bottom, and I'm going to change it to a positive 4 power. Okay, so that's going to be 1 over negative 5 times negative 5 times negative 5 times negative 5. And that is 1 over 625. Now you notice these two negatives make a positive and these two negatives make a positive. So that's positive 625. Okay, now we're going to look at number 6. I have negative 5 to the negative 4. This means that 5 to the negative 4, that means 5 to the positive 4 has to go on the bottom, and that negative is just going to put it in the front. So that means 1 over negative. Now notice that negative only has one negative. It doesn't go to the 4th power. On the problem before it, we had parentheses around it. So that was negative 5, negative 5, negative 5, and negative 5. What this means is negative, only one of them, 5 times 5 times 5 times 5, which is 1 over 625, and it is negative. That negative can go on the top, the bottom, or the middle. Now, be really careful. If negative 3 to the negative 4, this negative 3, the base is negative because the negative is inside the parentheses. But this one, that negative just means negative, 1 negative, and then 3 is to the negative 4 power. Okay, example number 7. Okay, write down example 7. This has to evaluate the expression for the variable. So we're going to take 4 and plug it into x. So that gives me 4 to the negative 2. Remember, a negative exponent means it has to switch to the bottom. So that's 4 to the positive 2. When there's nothing on top, you put a 1. So that answer is going to be 1 over 16. example 8. I'm going to plug in a is 5, b is negative 3. So negative 2, a is 5 to the 0, b is negative 3 to the negative 4. We're going to look at each piece of this separately. This negative 2 is a negative number. Now the negative number does not mean it goes on the bottom. This is just a negative 2. Same as this is a negative 3. Now that negative exponent up there is going to make that part go on the bottom. Now that negative 2 is to the first power. If it's a positive exponent, it stays right where it is. Negative exponent, it changes places, and a 0 exponent is going to be 1. So this negative 2 to the first power is going to stay on the top negative 2. I'm not going to put the 1 power up there. 5 to the 0 is 1. I don't need to put the 1 here either. And negative 3 to the negative 4 is going to switch to the bottom, negative 3 to the positive 4. So that would be negative 2 over negative 3 times negative 3 times negative 3 times negative 3, which is negative 2 over 3 times 3 is 9 times 3, 27 times 3 is 81. Now the 81 is a positive because we have 4 negatives multiplied together, which turn into a positive. Okay, number 9. This 7 is to the first power. The w is to the negative 4 power. So that means that the 7 is going to go where? On the top, because it's a positive exponent, it stays where it is. And then w to the negative 4 is going to go to the bottom. Number 10. This negative 5 is not a negative exponent. It's just a negative number. It's to the positive 1 power. So, yep, you're right. It's going to stay on the top. This k is a negative exponent. Since it's in the denominator, it's going to switch to the top and turn into a positive exponent. That's the end. All right, number 11. Number 11. Stop, pause it for just a moment and see if you can work it, and then come back to me. I'll be waiting right here. Okay, I think you've tried this problem now. A to the 0 turns into a 1. I don't need to write anything down. B to the negative 2 is going to switch to the bottom. B to the positive 2. C to the negative 3 is on the denominator, so it's going to switch to the numerator and turn into a positive. D to the 6 is a positive. That means stay where it is, so D to the 6 is going to go on the bottom. All right, guys, that's the end. Bring those 11 examples back tomorrow. Thanks a lot. Have a great evening. Bye.